In this lesson, we will explore first differences. In this, we are going to use a table of values to determine a linear relationship between two variables. Let's take, for example, this equation, y is equal to 2x. And I might not be sure if this is a linear relationship, so I'm going to have to apply my table of values. So first I'm going to start off with an x value and then determine what the y value will be for this equation. So if x is equal to 0, if I use my equation, y is equal to 2, and if x is equal to 0, then y is also equal to 0, and I put it into my table of values. Same for if x is equal to 1, I go through the same thing and I determine that y is now equal to 2. If x is equal to 2, I can figure it out. Y is equal to 2 times 2, which equals to 4, and I can put it down here. 3 gives me 6, 4 will give me 8. So that's my table of values for my equation, y is equal to 2x. First differences is just the difference between the two different y values in consecutive order. So here I have 2 and 0. Difference between them, 2 minus 0 is 2. I do the same for the next consecutive y value. 4 subtract 2 also gives me 2. 6 subtract 4, also 2. 8 subtract 6 also gives me 2. I can see that from my first differences that I'm always getting a consistent 2. So whenever I get a consistent number in my first differences, I know that this is a linear relation. So whenever we get this consistent first difference, we know that it is a linear relation. Now let's take, for example, a very similar equation, y is equal to x squared. Same thing, I have an x and a y, table of values. I start at 0, x to 0 squared is also 0. 1 squared is also 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. I do a very similar first difference. Difference between 1 and 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. And 16 minus 9 is 7. These are inconsistent. Therefore, this y equals x squared is not linear. So, first differences right away can tell me, once I do these differences between the y values, whether or not this equation is linear. This also works if I have, let's say, an equation, y is equal to x plus 6. Let's try this one. Here I have x and I have y, but when x is 0, y is equal to 6. Okay? When x is equal to 1, y is equal to 7. When x is equal to 2, y is equal to 8, 3, 9, 4, 10. Again, I can just take the first differences. The difference between 7 and 6 is 1. Difference between 8 and 7, also 1. 9 and 8, 1. 10 and 9, 1. So here, I notice that they're all consistent, they're all the same, therefore it is linear, which is great. So this works not only for a direct variation, but also here in my partial variation case. If I have, let's say, any other sort of exponent other than 1 in my equation, I know that it should be not linear. So things that are x squared, or square root of x, or x cubed, these guys are all not linear. If I'm just given a table of values, I can just simply figure out the first differences and therefore determine whether or not the relationship is linear.